Hey everybody, so in this video we're going to continue talking about applications of finding the vertex, and we're going to do some word problems together. Okay, so this one says a breeder of horses wants to fence 2 rectangular grazing areas along a river with 600 meters of fence. Okay, and it shows in the picture how those 2 areas should be split up. Okay, and then this part here is supposed to be the river. Okay, and it says that he does not need to fence along the river. Okay. So part A says write an equation about perimeter length and width. So we're going to go ahead and label some of these things. So I'm going to label this length here as the length, okay? And I'm going to label this side here as W, okay? Now that also means that this other side is W, okay? And the center is also W. So when we're looking at the total amount of fencing that he's going to have to do, he'll be fencing 1, 2, 3 W and L, okay, for the total amount of fencing, which was given as 600. Okay. All right. Now we're going to look at part B. It says use your answer from part A to write an expression for the length in terms of the width. Okay, so remember, length in terms of width means we're going to write length equals, okay, and then it should only have numbers and W on the other side. Okay, so we're going to use this first equation, okay, and we're going to subtract 3W from both sides. Okay, so we would end up with this, okay? Since it says an expression, we're going to focus on this part. Okay, but we know that this part is equal to the length. Okay. Now this says write an expression for the total area in terms of W. Okay, so we know that area is length times width for a rectangle, right, which this is rectangular. Okay, but it says in terms of W. Okay, so that means that we can't have L in here. We need to only have numerical values and W. Okay, so this is when we're going to use our expression from part B, okay, to replace L with this expression that is equal to L but only has W in it. Okay, so this is L and this is W. Okay, so we're still doing length times width, but now we have something that is in terms of W. Okay, and now I'm actually going to write this in standard form. Okay, so that we can see what type of equation it is. Okay, and then we can see it's a quadratic, right? It's a W squared type equation. Okay, for what width is the total area largest? Okay, so we're talking about a quadratic that's facing down. Okay, so the area is going to be largest at the vertex. Okay, so it is asking for the width of the vertex. Okay, so we're going to use our formula minus b over 2a. Okay, so for us this is minus 600 over 2 times negative 3. Okay, so this would be 100. Okay, so for what width is the total area largest? We would have width of 100 meters. Okay, and then find the largest area that can be enclosed, right? So now that we have a value for W, we can plug this in to find the area. Okay, so 100 squared is 10,000, so this is going to be minus 30,000. Okay, plus 60,000. So this will be 30,000. Okay, so what is the largest area that can be enclosed? The largest area is 30,000 square meters. Okay. All right, let's look at another example. Okay. An entrepreneur buys an apartment complex with 40 units. The previous owner charged $240 per month for a single apartment and rented 32 apartments at that price. Okay. He discovers that for every $20 he raises the rent, another apartment stands vacant. Okay. So let X be the amount that he raises the rent by. Okay. So write an expression for the new price in terms of X. Okay. So we're going to start with the previous amount, which is $240. Okay. And then we're going to add how much he's raised the cost. Well, he raises the rent by X. Okay. So the new price is going to be $240 plus X. Okay. Write an expression for the number of apartments rented in terms of X. Okay. So we're going to start with the number of apartments that are rented right now, which is 32. Okay. And we're going to subtract the number of people, okay, who move out. Okay. So if he is raising the rent by $20, one person will move out, right? So when X is 20, okay, the number of people who move out is 1. Now, if he raises the rent $40, we know that 2 people will move out. So when X is 40, the number of people who move out is 2. Okay. If he raises the rent by $60, then we know that 3 people will move out. Okay. So the way that we're figuring this out, right, is we're taking the number of dollars that he's raised the rent, okay, and we're saying how many $20 is that, right? How many times has it been raised by $20? So what we're really doing is dividing by 20. Okay. All right. Now write an expression for the total revenue. Okay. So his revenue is going to be the price per apartment times the number of apartments rented. Okay. So for us, we know the price per apartment, that was part A. Okay. And the number of apartments rented, that was part B. Okay. All right. What price should he charge to maximize his revenue? So the first thing I'm going to do is multiply this out. Okay. So 240 times 32. That's 7,680. Okay. Then 240 times x over 20. Okay, so 240 divided by 20 is 12. Okay, then x times 32. Then x times x over 20, right? All right, so let's put this in standard form. Negative 12 plus 32 is 20x plus 7,680. Okay. All right, so he wants to maximize his revenue, right? He's trying to get the largest possible y value. So we have a parabola that faces down. Okay, so the maximum is going to be at the vertex. Okay, so we're going to find the x value of the vertex. Okay, so we'll have minus 20 over 2 times A, which is minus 1 over 20. Okay. And now we're going to actually calculate what this is. So it's going to be positive because we have two negatives here. Okay. 2 over 20 is 1 over 10. Okay, so this is 200. All right. And now, little cat in the shot here. Okay. We're going to make sure that we're actually answering the question. Okay, so it says what price should he charge, but X isn't the price, right? X is the amount that he should raise the price. Okay, so his actual rent is going to be $240 plus 200, right? So the new rent, the rent that he should charge to maximize his revenue, is $440. Okay. All right. Then it says how many apartments are being rented. Okay, so the number of apartments being rented was 32 minus x over 20. Okay, and we know that x is going to be 200 at the vertex. So we'll have 32 minus 200 over 20. Okay, so 32 minus 10, which is 22. Okay, so even though this is his maximum revenue, only 22 out of his 40 apartments are being rented. Okay. All right. So those were the examples I wanted to go through in this video. Let me know if you have any questions, and I will see you guys soon.